Good morning, students. Myself E. Banu Prasad, working as an assistant professor in Vignan Nirula Institute of Technology and Science for Women. And today lecture we will discuss about the phototransistor. Yeah, this is the symbol for the phototransistor. This is emitter, base, collector, and the light is falling on your phototransistor. So mainly the difference between your phototransistor and photodiode is the sensitivity of your phototransistor is high, so then your photodiode. And if you see the schematic representation of your phototransistor, so it will be this is a N-type, so P-type semiconductor and N-type semiconductor. So always, so we are using and reverse bias to your phototransistor, and due to this reverse bias we will get the depletion region here, and here we are using one more lens. So within this lens the light has to be fall, and the amount of that light is converted into so electrical signal. So basically the working of your phototransistor is which will convert the light into electrical signal. So here remember one point. So the amount of light, the amount of light which falls on this junction J2, this is called junction J2, that light only converted into the collector current. And the main drawback of your phototransistor is even though if there is no light, here the two conditions are there, that is no light and the light is on. In this condition the collector current is equal to so beta plus 1 into ICO. So this ICO is the reverse saturation current. So due to the propagation of carriers or the moving of the carriers due to this positive polarity from this base region to so this collector region. So here the majority carriers are holes and here the majority carriers are electrons, and without any light these electrons will attracted to this positive charge, and due to this the movement of the carriers we will get the current IC equal to beta plus 1 into ICO. So this is called the reverse saturation current. So whenever if light is on, so light is on, so in this case we will get the current of your phototransistor is IC equal to so beta plus 1 into ICO plus IL. This is due to the load current. So in this light there is a photon energy, so that energy will have the combination of electron and holes. So whenever that light falls on this junction J2, that photon energy will be separated here and the carriers will be moved toward the positive charge, and due to that we will get the current IC. So that is called, so IC is equal to beta plus 1 into ICO plus IL. Here IL is a load current, and beta is the current gain parameter of your common base configuration. So by whenever if you observe the characteristics of the phototransistor, the characteristics of your phototransistor. So it will be like this. This is the input and output. This is VCO, this is VCE, the voltage across your emitter and collector, and this is the current IC in milliamperes. See, the characteristics of your phototransistor will be so like this. So here this is 0 lux, we will call it as a 0 lux, and we will call it as a 100 lux, a 200, or 300. It means that this is the lux, means the intensity of your light. Intensity of light. So from this graph we can say that the amount of the produced collector current of your phototransistors is purely based on the intensity of light that falls on your phototransistor at junction J2, so not on the applied reverse bias voltage. This is very, very important note. The amount of collector current produced by your phototransistor so will be depend upon the amount of light intensity which falls on your junction J2 of your phototransistor, not on the applied voltage. So this is the characteristics of your phototransistors, and these are all the current equations. Thank you.